Okay, class, welcome sa kanina po nga video. This video kay will talk about your problem set. Very interesting and fun. I think it's gonna be fun gini siya nga problem set because you will be using real world data, specifically on COVID-19 nga data diri sa Central Visayas. Okay, so I will be uploading this data file sa inyong problem set sa Google Classroom. Okay, so take a look at this data that we have. So this is actual data taken from DDOH Region 7 Central Visayas. So sa imong leftmost as mong first column, you have the dates. Actually ako na nagbutang ani sa date. This is from, take a look at the date, starting from February 21 up to June 15. Now for your case, para smooth ang inyong data kay kanios, I don't know what happened sa kanila kwan. I think wala pa gyud ni na test or wala pa testing na buhat ani, that's why ang imong total cases is wala siya nag-change, isa pa. So sa inyong data analysis, magsugod lang mo din sa March 12, take note of that. So magsugod mo sa March 12 nga data padulong sa June 15. Okay? So mo na yung pag-extract sa data para mag-solve ta sa, we can do forecast and modeling using the SIRD SIRD model. So the second column is just the date. Numbering na siya from 1 up to sa siya nga date. Pwede na siya i-omit kapot, pwede na siya wala. Then we have the confirmed cases. So this is active cases ni siya, kaning new confirmed cases. Pila ang madugang na COVID-19 cases every day. So as you can see here, na isa nga new confirmed cases and the total number of confirmed cases is 1. Okay? The second day is wala until February, until March 18, wala yung active new cases, wala na dugang. So that would mean na imong total confirmed cases kay 1 rapport because this is cumulative. Cumulative man ni siya. So wala na kay change ana. And so on. Magdugang na pud siya og cases din and ang pagdugang sa number of cases muna limitation sa data because we just don't know unsay ilahang problema sa pagkuha sa data. It could be, we cannot tell kung unsay accuracy basta kay just rely on this data nga ilang gihatag. Okay? And dagdag factors man nga mo increase ang cases could be ang infection is nikalat gyud, or it could be nanaghan ng pod ang testing. So I have pa. And then for the next column we have the infected. So sa total number of cases na siya tulo ka partition, kinsa diha ang infected, kinsa ang naka-recover, and kinsa ang katong na-remove o namatay. Okay. So as I've discussed sa lesson, this is a SIRD model atong gamiton wherein once na maka-recover ang imuhang patient from the disease, he or she will gain immunity. So she or he will not be part of the susceptible population anymore. So ma-remove na siya. So two ways na ma-remove ang person or individual from the susceptible population is through recovery and death. So this is our data. So first thing, you can plot this ang SIRD ano niya. You can plot the x-axis is days and then y-axis is SIRD. You can plot the actual data and then later on i-plot ninyo ang forecast na using the SIRD model. Okay? So for your problem set, we will be using this one. So this is a paper this is a very recent paper posted March 12, 2020. And it's a very good paper. Ako na siyang we actually review this one and use this method also in doing our uh, epidemiology mathematical modeling for COVID-19. So this paper is from Anastasopoulos and his co-authors. Please take time also to read the details. Okay. So what are you going to do for the objective for your problem set is kani naman siya. So the objective is sign naman siya. Okay. First is, of course, you have your data. So you get the data. Oops. Okay. You have your data. Okay. And then imo siyang i-extract from the Excel file to the MATLAB. Okay, imo siyang i-read. You read the file and then you extract it sa MATLAB. And then you extract, so extract mo ang data, i-separate mo ang SIRD data. Okay, i-separate, i-extract mo siya. And from here, kasi ang data nimo is from katong example ganina is from Feb 21 ba to? Sorry. It's March 12. Let's say March 12 up to June 15. Ang imong data acquisition, yung gigamit nga data para mas nindot ang ato ang inyong gawas nga result. Then after this, out from this raw data, you will get an estimate of those constants. Katawit ang we have constants alpha, beta, gamma, and later on, and in return, makuha nimo ang R, right? Or R naught. This is the infection rate. And then you have, this is the check in siya. Death rate. Recovery, okay. So recovery rate na siya. And then this is the death rate. And this is the reproduction number. Okay? Once nga makuha na nimo ni nga mga values bitaw, then it's easy for you to make a forecast and to plot the SIRD. Right? Kaya ang katong SIRD na to is SIRD, a function of this, of parameters. Right? So, mga parameters niya, we have the alpha, beta, and gamma. So, the question now is, okay, once na makuha na nimo siya, ma-plot nimo ang imong SIRD. Okay? You can also plot ang changes sa imong alpha, beta, gamma from the first date, March 12 to June 15. Okay? So, imo na i-plot, then, the more magkadaghan imong data, magka-nindot ang imong approximation sa alpha, beta, and gamma. So, you have values sa alpha, beta, gamma for each day nga imong, let's say, window. Let's say, masugod ka og 6 nga window lang from March 12 up to, say, 18. So, March 12 to March 18, that's your first approximation data for alpha, beta, and gamma. And then, after that, mag-interval na din ka or mag-window din ka 1 day until June 15. So, you get a different set of values of alpha, beta, and gamma up to June 15, starting March 18. So, makakuha kang plot na you can see the variation of that alpha, beta, and gamma. Now, para sa inyong pag-plot sa SIRD, ang gamiton ninyo is katong pinaka-last na dayon nga value sa alpha, beta, gamma, which is sa June 15. Okay, mawala siyang muna close to the real value or accurate, mas accurate siya nga value sa imong parameters for you to make a forecast sa imong SIRD. So, mo ni mong gamiton dayon para paano. So, mo ni mong gamiton. It's not working. Anyway, so mo ni mong gamiton dayon para maka-plot ka, maka-make a forecast sa SIRD. But the question now is, how do we calculate or approximate these parameters, alpha, beta, and gamma? So it's given in this paper. So explicitly show gini nila din. And okay, let's take a look at the methodology sa kaninga paper. So take a look at these equations. Muna ang gamiton, right, para pagkuha sa surd. So we need these values. We have the alpha, beta, and gamma para makamake the forecast. So in their paper, muna ang mga formula gamiton to get this one is the death rate, and then this is the recovery. So paunin mo this is fatality or death rate. This is fatality rate, and then this is the recovery. So this is how you do it. Pag-approximate nimo sa this one, but na mas-simplify na siya using this. So kani ang gamiton. Sorry for that. So kani ang gamiton. Okay. For the fatality rate. And then the recovery. Okay. Now, what are these formulas? C is for cumulative change sa imong infected, cumulative change sa imong death, cumulative change sa imong recovered. Okay? So, kano siya, na siya formula dito sa taas. How do we get this boldface C delta A? So, it's given in this equation. Okay, sorry. Ay, asa mo to? This one. Tara. So this boldface cumulative delta x, where delta x kay kuan tara ang x nimo is could be I, R, or D. So ang cumulative delta x, this one, the boldface, is a matrix ni siya or a column vector. So at t by 1, t is katong time. Okay? Katong pila ka unsa man kadako ang imong length sa time. So it's a t by 1 column vector containing the corresponding cumulative numbers up to time t, where this one is defined as this. Tada. Okay? So in general, mo ni siya ang gamit. You get this one, then makuha nimo ang kaning boldface delta x, and then in return you get the column cumulative delta xt. Okay, so you can easily program this in MATLAB because MATLAB handles efficiently matrix problems. So these are all matrix vector. So once you do that successfully, you can get the fatality rate and the recovery rate, the approximate, okay, the gamma and the beta. Now how about alpha, right? Alpha is for infection. You can get alpha through this. Tara, magamit niyo muna siya. So this is like a fitting, a non-linear. Talaga magamit niyo ang kanisiya. LSQ, least square non-linear of MATLAB. Okay? Ang buhaton naman sa LSQ, non-lin of MATLAB, is to minimize kung say dapat value sa imuhang alpha nga given ang beta o gamma such that ang ihang sum niya is, ang argument niya, the sum of this is minimum. Okay? So that this can easily be handled by LSQ non-lin. So you get an approximate value here of alpha. So alpha is makuha nimo ang ihang vector pod niya. Say from March 12 up to June 15. Then we're going to use the late pinaka-end nga result sa alpha. The same is true with the beta and and gamma. So once you have this beta, gamma, and alpha, now you're good to go. You can now plot. You can superimpose the plot. You have T. Let's say you plot for you will going to plot the infection. Let's say mo na siya ang infection. This is the infection data. And then sa inyong simulation dayon, given the alpha, beta, and gamma, these alpha, beta, and gamma were calculated and extracted from the data itself. So, imo siya i-superimpose na yan. Kasi your theoretical is color green. Okay. So, mukha na din na siya. Let's say this is your theoretical. Oh, nabi fit kayo. Assuming lang na fit yan na siya. So, this would be the infections. Let's say proportion of population. Kasi unsa na siya nga day diha. Let's say this is day 1, this is day 500, and then this is day 200, maybe. So, nadira ang maximum peak, ang imong peak sa imong infection, and then die out na rin siya. Okay. So, this is a typical graph of an epidemic or a pandemic. Okay. So, let's say ang proportion sa population nga na-infect ay 0.3. So, around 30% maybe. So, you can get a plot out of this. So, I hope nakuha na itong mga steps. And, by the way, ang mga kailangan ng mga tools and mga materials for you to accomplish this problem set will be uploaded in Google Classroom. And what else? Maybe I'm going to upload one video tutorial on how to read and extract data from Excel if you want that, and also doing nonlinear fitting maybe. So kana siya. So all the best sa inyong problem set, and enjoy lang, and do things to accomplish this gradually. Hinahinay lang, but basta dili lang nimo nga matigom nimo siya at the end. So mao na akong advice. So if you have spare time, let's say 30 minutes maybe, or 1 hour a day, then that would be enough. Okay, so that's all, and good luck and God bless.